All right, welcome back from lunch. I confess not having lunch because I was holed up in my hotel room, preparing for this presentation. So be merciful, if you would. So yes, finding truth in legacy systems. So this is mainly a talk about the experience I've had at Portware, which is a financial company, not on the cutting edge IT-wise, but financial company, does a lot of on-premise software, also software in our cloud, dealing with, as a release engineer, trying to support and improve some of our products. So it's a lot from my personal experience mixed up with what I see in the best practices in the literature, trying to figure out some lessons from the two. Very much eager for feedback from all of you about things I've gotten wrong, things I've missed, and so forth. So that said, let's just jump right into it. So that's me and my release engineering department. We do not have an integrated everyone in one group type thing at Portware. So devs have their separate group from product managers, from QA, from support. And release engineering sort of sits on the outside, tries to get people to notice us, tries to generate authority where we have none type thing, which maybe some of you are in the same boot. Sort of basically a DevOps role, but trying to streamline those four groups up there that existed before our department was created. Okay, so talking about legacy systems. For which we can say, let's just imagine a black box, okay? So this is something that, let's say, comes into your attention that you have to try to deal with it. You have to try to improve. Maybe one day you go into the office and it's on your desk. Maybe somebody left the office, left the company, left this on their desk. You have to deal with it. In any case, there's a legacy system there. It's confronting you. Maybe it's sitting in the corner of the playground. Nobody wants to touch it. Everyone's having fun playing with each other. They know about this thing in the corner, but no one wants to deal with it. Or maybe people have just forgotten about it. What the heck is that thing over there? No one's paying any attention to it. You notice it one day, and you step up and you say, you know what? I have nothing to do. Let's improve that legacy system that I found in the corner. Maybe it's important. Okay, that's unlikely. But let's just say you have a legacy system and you need to improve it. You need to deal with it. Let's apply our standard stuff to it. Let's DevOps it. Release engineering, config management. Or to summarize it, let's say, let's do continuous delivery. Okay, it's too long for a lot of the slides, so let's just say CD. Let's continuous delivery it. Let's CD it. Let's improve that legacy system. Now, when I started doing release engineering, started learning about configuration management, a lot of talk about source of truth. Lots of different definitions about what source of truth means. So what I'd kind of like to do in this presentation is think about how we deal with legacy systems from the perspective of trying to do continuous delivery, and at the same time try to say a couple of things about what source of truth means, and how we could try to keep that in mind while we're trying to improve the legacy systems that we find. Okay, so sounds like an abstract philosophical question. Do we actually need a room full of philosophers to deal with this? Maybe we do, but let's focus on just a couple of them. This is Raphael's School of Athens in the Vatican. But let's zoom in the center, okay? This guy on the left, this is Plato, right? 450 BC, thereabouts, okay? We know him probably from the Republic. His book he's holding here is actually the Timaeus. And the Timaeus has this idea of a person, Plato doesn't actually say a person, but let's say a force reaching down from the center of the universe, from the center of ontological reality, whatever, and kind of saying, here's how the world should work. Here's how the world should be structured. This idea of truth, right, that for us would mean there's a source somewhere, there's the spec, and the spec specifies what should be true. And if we want to do continuous delivery, we want to do configuration management, we go and we find that spec. The spec refers to a form of, we might say, what is this type of truth? Top-down prescriptive truth. It prescribes the way that things should be, right? And it comes from the top, from a single source. For us, who is this Platonic demiurge, right? It's probably maybe the product manager, less glamorous than in the William Blake picture there, but the product manager, right, who says, here are the features that should exist inside a system, and if you want to do your configuration management stuff to the system, here's how the box should work, here's the things that should be on it, now go and make that happen, be able to replicate it, make sure it doesn't veer from that, and so forth. Unfortunately, for a legacy system, our product manager might look like this. What the heck was in those feature boxes? How the heck was that system supposed to work? Were those features ever deployed? Did the customer modify them? Does the spec even exist? Is the spec Does it bear any resemblance to reality whatsoever? In other words, for legacy systems, we're kind of back in this situation, right? That there often is no person reaching down from the heaven, handing us a speck that we can just feed into our chef system or our salt system or our Ansible or Puppet system, whatever. So we have to take a slightly different approach, especially because we suspect that the legacy system may have all sorts of unpleasant things in it we don't want to deal with. Given that there's no spec, given our suspicion that the legacy system may be actually rather unpleasant, maybe we can just leave it alone. Maybe we don't have to do anything with it after all, given that no one is around to tell us what to do. I'm sure you've all worked with people who work best when somebody tells them exactly what to do, right? So if you're in a DevOps situation, that's often not what you can do, especially with legacy systems. Can we leave it alone? Probably not. 4 reasons at least, and these are somewhat arbitrary, obviously, but 4 reasons. Let's go in reverse order. Leave it alone, it's going to break one day. It's hard to roll out, it's hard to deploy, it's slow to deploy. When problems go wrong, they're hard to figure out, they're hard to debug. And it's hard to enhance it or to improve it in any way whatsoever, right? So for all these reasons, maybe if it turns out that it is kind of important to customers, usually you don't know this until something breaks, right? But let's just assume that you know in advance. Then maybe you can't leave it alone. You have to apply your continuous delivery magic. Okay, focus here on this one. I'm pointing at my screen, which is not going to do you guys any good. One day it's going to break, right? So there's input, there's output. One day that output is going to go bad. It's going to break. So what can you do to prevent that from happening? How can we focus continuous delivery on that specific problem to begin with, preventing it from breaking down the line? This is a standard approach. What you want to do to prevent it from breaking down the line is somehow identify all the inputs to the system, or the major ones at least, and freeze them, control them, make sure you can isolate all of them. So let's say, for example, you put all of your software that's being pulled onto the system into internal repos instead of external repos on the internet, right? You freeze all of that, you look at what, and then you measure the output that's coming out. You know what the inputs are supposed to be that are relevant for your users. You know what the outputs are supposed to be. And you freeze that using some sort of acceptance test harness, which is like a developer term, right? But you all know what I mean, right? It doesn't have to be JUnit or whatever. It could just be some sort of script that you write that simulates or replicates what the user does and watches the output and verifies that the assertions that it asserts over here, certain states that turn out to be true. So if you do this, then you'll be able to see if a developer does something, adds a change on that causes it to die, causes it to vary its expected output, or if an external dependency changes. So you can at least prevent it from getting any worse. You can freeze it. This is the standard approach talked about in books that deal with refactoring in general and legacy software in particular, like Michael Feathers, Martin Fowler, a little bit Jez Humboldt continuous delivery approach. You wrap an acceptance test around it to freeze it to prevent it from getting any worse. Okay? This is actually why Feather's definition of what a legacy system is, because who knows what a legacy system is definitionally, if that's a word, right? Feather's definition is a legacy system is simply any system without tests, because if it doesn't have any tests around it, then you can't know if it breaks, right? So if we go back to that great slide where the output turned red like that, right, simulating breakage there, how can you actually see that color? You can only see that color if there's a test harness around it. Okay, so for Feathers, if it doesn't have tests, that means it could be breaking and you don't know it, therefore it's legacy. It doesn't have to be, in other words, 20 years old. That's why he says, you're writing code, people in your company are writing code right now that is legacy code for that reason, if they're writing it without tests. Okay, so this fits in with the whole test-driven development approach. You can think about it from a test-driven ops approach, right, that some people communicate with. Okay, so, but I wanna using an academically term like problematize Feather's term here. It's not entirely accurate for the situation of legacy systems. Okay, so if you're writing code today, probably, or you're building a system, probably you know how it's supposed to work. In other words, you know what the likely inputs are. You know what the outputs are that you expect. But with legacy systems that we inherit, we don't necessarily know what's supposed to go in or what's supposed to go out. So what are the expected behaviors? What are the outputs, right? It makes it harder, in other words, to wrap a test harness around a legacy system and make sure that it's doing what it's supposed to if we don't know what it's supposed to do in the first place, right? Which will often be the case with systems that we inherit, right? That are legacies that show up on our desk one day. So let's turn over to this guy, standing next to Plato, Aristotle, okay, around the same time, a little bit after him. So he has a different approach. Specifically, as you can see in the zoom here, this is a famous picture, Plato's pointing up, top-down prescriptive truth. Aristotle's saying, wait, hold on. Let's start with what's on the ground. Let's start by figuring out how the world actually exists, how our systems, in other words, actually exist, before we go and talk about how they're supposed to exist. And in the case of legacy systems, right, we don't know what's supposed to be up there. So we have to start with what we see, what we can touch with our hands. This confusion between, or complementary notions of truth, let's say, about where we should start between Plato and Aristotle, you see show up in the discussions about sources of truth in the literature on the web. So here's an example from the Puppet website. So Hiera is a way that you can do Puppet inputs, right? So this person here is talking about how your Hiera files can be sources of truth for how your systems, for your systems and your configuration management tool in Puppet. Here's another piece on the Puppet website about Puppet Enterprise, shilling for Puppet Enterprise, right? So Puppet Enterprise can be a single source of truth. And what they mean here is completely different. What they mean here is not how your configuration management system should be building systems, but what's actually on your systems, how much hardware they have, how much memory they have. And they're using the same term, right? And that sort of slippage is common when people talk about configuration management and truth. So, two different approaches, right? The Aristotelian and Platonic approach, let's say. So let's go back to this. We don't know what our input scenarios are supposed to be. If we start with the approach, Aristotle's approach, right, the descriptive approach, we start out with what's on the ground. And we say, all right, I don't know how the system is supposed to work. Let's just start with how the system actually is working right now. Do we actually even know how our legacy system is working? Probably not. So we have to go and do a big investigation. How it's operating right now. What are all of its outputs? Different days. What are the cron jobs that run? What are the things that it spits out? What are the ways that people interact with it? Right? We know this output now. Maybe we try to study that. We figure it out. So the question mark goes away. This is just pure descriptive truth. We're not actually saying at this moment, this is how the system is supposed to be. We're just trying to learn how it actually is. Right? Is that enough? Top-down truth doesn't work for us. Can we just stay with pure descriptive truth in the box? No. So here's an interesting quote by Feathers that will lead us into the next idea here. Correct behavior is defined by what the set of classes did yesterday or what it does right now, not by any external standard of correctness. No one knows whether the code is correct or not. Or in our terms, no one knows if the system is correct or not. So, in other words, correct behavior is defined by the way that it's working now. So we're going to say, maybe when we're dealing with legacy systems, not only this is the way the system is working, but let's start by assuming that this is the way the system is supposed to be working, right? So a descriptive into prescriptive move, right? So, okay, whatever that behavior is that's coming out the other side, let's assume that that's the way that it's supposed to work. So now we have the facts on the ground. We say not only is that the case of what's on the box, but that's what's supposed to be on the box. That's what should be on the box. So this is prescriptive truth, saying the system is supposed to be a certain way that comes from the bottom up, filtering up from the bottom. Back to our philosophers for a second. That's the Timaeus, as I mentioned, about God reaching down from the heavens, saying how the world should work. This is ethics that he's holding. The interesting thing about Aristotle's approach to ethics compared to people nowadays when they write about ethics is a lot of the time when we think about ethics, we think about like the Ten Commandments, right? Or we think in the abstract, what is the correct way? Should one ever lie? Like that, right? But that's not the way that Aristotle works. The way that Aristotle comes up with ethics is he looks at the way that people live in the world and interact with each other. And he says, okay, let's try to figure out from the way that people act, from that set of behavior, what's the subset of those behaviors that are ethical, but somehow inferring it from actual behavior. And that's kind of what we're getting at here, right? You look at the way that your system is behaving, and you somehow try to infer from it, from what you can find in the box, the way that it actually should be behaving. So the descriptive truth moves into sort of a bottom-up prescriptive truth. Let me give you a couple of examples. So when I started out in tech, or support, I used to run a support team a while ago, and we have a monitoring console, and these errors would come up. Right? We'd have a log scraper, and these logs would come up from a daemon log, and it would be like this mysterious error. And we're like, I don't know, is that a problem? It's a warning, it's an error, it looks like it could be a problem. You go to the developer, and whenever I would bring this to the developer, I'd be waiting for the developer to say, all right, hold on. look at a book, and like there would be the explanation of what the code, like what the error meant, and he would know what to do. And I kept on expecting that for a long time for some reason. But instead, what did the developers always do? They would just go to the box, say, okay, let's see, what the code is actually on the box. They'd go to their source control system, they'd look at the code, and they'd try to kind of figure out from the code how the system should be working at the moment, and then have that error fit in, say, okay, well, it looks like it's supposed to be working like this, but I can see, this exception is because of this case, or it's not even an exception, it's just a log line, and it shouldn't be happening that way. In other words, the developers wouldn't go, at least in my experience, and consult a spec. They would just look at the code and try to infer from it the difference between correct behavior and incorrect behavior. Another example, more in the ops world. In Puppet, which is what I'm more familiar with, what we use, there's this concept of facts on the box. And when you do a sync on a box, as I'm sure a lot of you know, when you do a sync on the box, you can do things like say, all right, check the fact that says whether this is a VM or not. If it's a VM, deploy VMware tools, otherwise don't, type thing, right? So those are native facts that are present on the box, pure descriptive data. But you can also write custom facts. And for legacy systems, you can write a custom fact that says something like, okay, if Oracle 12c happens to be on the box, then do all this other stuff, deploy all this other code. If it isn't, do this instead. Should Oracle 12c be on the box? I don't know. But you write a fact that just says, okay, I don't know if it's supposed to be there, but I know the databases are important to the way this legacy system works, and sometimes it seems to do different things depending on what's there. So I'll key off behavior over what I happen to find there without actually knowing for real whether it's supposed to be there in the first place, right? Because an account manager may say, you were supposed to upgrade from Oracle 12c last month in that box, right? But you don't know, right? You don't know that yet. So you just start by assuming what's there. And then I'll have to skip over this really, but there is this idea that in some systems, maybe they're complex enough and they stew enough long over time that so there's sort of a primordial ooze of interesting stuff in your box, and out of that arises these behaviors that your customers love that actually no one planned for, but actually you want to hold on to them. So you might discover all these things and you might decide you want to actually try to put that into your spec so you keep on manifesting it for future boxes. Okay, let's go back to this. So let's see if I can pick up the thread. Is this good now, what we have so far? If we can 100% prevent it from breaking, is that enough to leave it as a legacy? Leave it in the legacy. Leave it in the legacy camp. Do we have to go any further than that? We can, if we've wrapped that test harness around it, right, and we're reading from the if we're reading from the descriptive truth of what's on the box, we can, get this going, I guess is what I was getting at, get this going finally, right? So is that enough? And I think the answer here, next answer is probably not because of this problem. So how do we solve this problem? You've stabilized your legacy system, it's not going to break. Can you get it out in a quick enough time to your customers, let's say? So this is how you could do it. You have a QA box. How are you going to replicate this and get it to your customer? You're simply going to clone it, right? You're not going to build it from the inside out. You're just going to, let's say it's a VM, you're just going to take it and put it into UAT and then put it into prod, let's say. Or probably what you're going to do is you're going to start from the prod box and make sure that the box that QA is testing is an accurate copy of what's in production. What I'm getting at here is that for some legacy systems that you don't understand very well, you could just essentially put the thing into a zip, right? A whole file system into a zip, or the whole VM, and copy it over. And this may, I don't know, to some of you this may sound ridiculous, but trust me, this is how you can, this is some way that legacy systems are dealt with that people don't understand very well. And then of course, if you have a new customer that comes online, you can just give them a copy of what your existing customer has in production and then kind of tweak it slightly, right? And that can be your rollout model. And that can actually solve this problem over here. You can actually do deployments like that, and they can not take that long, not take super long, and then you solve that problem, right? Probably it's not going to be good enough in the long run, though, right? For one thing, you've frozen your system, but probably the system has been left alone to its own devices for long enough that it's not that great quality. It's probably not performing that well. There's probably existing bugs in it that need to be corrected. So someone is going to have to go in and not leave it in the state that it's in right now. It's going to have to be changed. And once you open it up to change, you're going to have a problem, right? The second law of thermodynamics, right? Which basically means, right, if you act upon the system with some input and you don't apply some sort of counteracting measure to it in some way, then you're going to get an increase of disorder inside the system. Or to use Yoder and Foote's terminology, you're going to get even more of a big ball of mud inside the system, right? This is their big paper back from the late 90s, right? That there's all these interesting different types of software architectures out there, but really there's only one type of software architecture that everything tends to, and that's the big ball of mud, where everything is kind of, right? There's 1,000 global variables, right, and a million different classes, and all these like weird little cron jobs, no one knows what they do, et cetera, right? So if there's any action on the system, that's going to happen. It could be external action. Your DNS system changes. Someone removes a DNS entry. Whoops, right? Or again, a third-party library changes. Or you have to move data centers, and you have to upgrade your VMware server. Or, there's a million things that can happen. And it's internal entropy can generate as well. If, again, any developer needs to make any change to it, and you're not doing anything inside the system internally, inside the black box, to make sure that the things inside the black box are preserving their order, then things are going to get more disorderly on average on the inside, making it more likely that this is going to happen, right? That it's going to break. So it's not enough, in other words, just to try to freeze it. And it's not enough just to try to replicate the whole legacy system. Insufficient. That's where you start by trying to stabilize things, right? Emergency triage to make sure it doesn't degenerate. But after that, you want to be able to build systems without having to clone them. And for me, at least, continuous delivery person, right, that's sort of like the functioning definition of legacy, right? If you can't deploy a system without cloning it, it's basically a legacy system. What is a legacy system? The same thing, or a system that's resistant to continuous delivery approaches. So, how do we go from here? How do we make that black box permeable to continuous delivery approaches? How do we open it up to improvements and to changes? Well, what are the pieces that are inside it, right? Hardware, operating system, software, config, all these pieces ideally, are going to be something that we have individual, more granular control over than we do if we leave it on just the black box level. Let's go back to our guys for a second. Top down, bottom up. So here are sort of a couple of points, general way of proceeding, and then I'll dive into some examples. We want to make our spec better. Maybe in the beginning, our spec, as I mentioned, is just something that says, I put a big zip file on the server over here. Periodically, my Puppet Sync downloads it and unzips the file. That's it, right? So that's not much of a spec. So you want to keep on adding to your spec and making it more and more granular as time goes on. How do you do that? You have to get more information about what's actually on the box for a legacy system before you can do number one. Figure out what are the things that are on the box that you actually want through some method, and then refactor your truth spec right up at the top. And you keep on going in the cycle and making it more and more robust as time goes on. So, I'll give a couple of examples of kind of how we have, some of these ways these happen at my company, and maybe this will, echo with some of your personal experiences. So let's start with the descriptive method. Okay, so when we started on this particular legacy system that I had in mind, we had a deployment mechanism. We had a deployment installer that would deploy some Java files, drop some Java files in. We had a bunch of Java files inside a package. You would run the installer against this package. You would drop them in place. But then you couldn't go to the box and say, hey, what's there? Like you couldn't ask it what jars were there. You couldn't ask it what packages had been deployed. Obviously, that's bad from a continuous delivery, right, config management approach, release engineering approach, because you can't say something like, all right, I know this box is supposed to have packages A, B, and C. It only has packages B and C, therefore let's deploy A. Right, if you don't know what's on the box. Now, the way that they were doing it at my company for this system earlier was they would keep track, like in a list somewhere, what they had deployed to the system, and they would just assume that that was correct, which is obviously not good enough, right? So we have to have the system itself know what's installed on it. So we just souped up the installer. So now I can say, this is what I have installed. I've installed these 10 files, check the checksums of those 10 files so I can know if somebody's touched them or corrupted them in some way. I can see if there's extra packages that were deployed that aren't there anymore, and I can see if there are packages that are supposed to be there that aren't there. Right, and we'll get to that one more in a second. And then once you have stats like that, information like that on the boxes, you can generate all sorts of interesting metrics. Going back to the metrics talk yesterday from Nicole at Chef, You can also set targets for those metrics, like, okay, currently 20% of the software in the company is deployed through this mechanism. By next March, I want it to be 40%, right? You go to your executive, you'll say 100%, right? Then you try to make it a little bit more realistic. But you can have some metrics attached to them. Ideally, metrics that would overlay with something about customer experiences, number of customer rollouts that have happened recently, number of bugs that have occurred, total number of software deployments that have happened. So that's sort of the bottom up. Let's say now you have your descriptive tools in the box. You have a good sense of what's on the box that you want to work with. Then you have to kind of figure out if what's there should be there. And this is sort of the standard DevOpsy stuff where you have to go around and canvas people, right? You talk to your developers about what's supposed to be there. Here you tell them, here's what's there. Is that what's supposed to be there? The product managers, right? The account managers. The account managers are the people who are, know the customers the best. So if the customers are having a bad experience with something, then the account manager will know that that feature is something the customer really wants or really doesn't want, and what problems are your support teams running into. And you can use that to kind of filter out what you find in the box to determine what's actually supposed to be there. And then you have to kind of sit with them, right? John Cordyback uses this term for muscle memory, for the things that people do reflexively without really thinking about it very much. So it may be that your support team is actually doing these manual steps for deploys, and if you ask them about it, they may not tell you. Not out of malice, right, but just because they're not even aware of what they're doing anymore. They do these things reflexively. Similarly for developers, okay, how do they actually package up the code, right? It may look like it's a neat package, but are they producing it through Jenkins or are they doing it on their desktop, for example? Okay, so let's say that we're getting now this stream of prescriptive information coming up from the bottom about the things that we want in our system. How do we actually use that to what would be an example of the type of process that you could go through to refactor that spec? So the general approach is something like this, right? You figure out a particular piece of the system, right? Particular block of software, or one system out of a set of 4 systems that you want to improve, that you want to make more continuous delivery responsive. Question is, can you focus on just that one system, on that one component? And you may not be able to if the systems are so intertwined with each other that any change at all that you introduce to one affects the others, and maybe it's not possible to wrap a test harness around it that can actually restrict and test the flow of inputs to that system. In other words, maybe there are so many inputs going in and out of the system that you can't actually test it properly. If that's the case, you can't focus on improving that one piece. The whole system may just be a block. So the way that we deal with this in coding, right, standard approaches for dealing with this in coding, applies, I think, to ops people as well. So when you're doing refactoring in code, standard approach for dealing with this type of thing is this. You have all the system pieces. You try to find 2 pieces that are important, that there's maybe just one link, big piece, big piece. Here's the piece that connects the 2. You look at that link that the data passes over for those 2. And you figure out the contract for that data flow. Like Java, you might say the interface, right? In other words, based on what I can see, what the code has, what's the data that's expected to go over? What form does it take? Is it JSON, YAML, for example, that type of thing, right? How many arguments? What are their data types? You figure all that out, what the actual expected flows are on either side, and then you can have something that steps in for that other component and simulates those flows. Once you have that, you can wrap your acceptance test harness around it, and then you can refactor it at will. This is the important part here, right? Breaking the components by providing simulated input, right? So that's a coding approach. We're talking here about like interfaces and classes and things like that, but the same approach to figuring out a piece of the system that links to others, trying to get as narrow as possible a link as you can find, trying to define what the behavior is over that link, and then once you've done that, simulating, replacing the guy on the other side with a simulated test harness. So let me give you an example about how that could work in the ops world, the way that it worked for us, for example, in one of these legacy systems that we dealt with. Here's our legacy system. We did as much configuration management stuff as we could, the easy stuff, right? This is usually the easy stuff. Build the hardware, okay, forget it, that's not easy. Get a server from someone, then build the operating system, that's easy. Deploy my cool tools onto the box, right? But then the actual legacy system is the software and the config, right? So we wanted to go on to, dealing with the software, trying to actually deploy it properly. So the way that they had originally for the system dealt with deploying the software was like this. They would have a ticketing system somewhere else, and in the ticketing system they would say something like, all right, here's a ticket, deploy ABC to the box, and someone would go and do that manually, as I mentioned, right? And then they'd have another ticket and they would say, okay, now deploy these two, and then another ticket and deploy this one, right? In other words, they had no list that this system, the configuration management system, could consult that would say, here's this software that's supposed to be on the box, now go and make sure that it's there. Okay, so we had to introduce that. So we came up with a new system, a deployment database, and started out with this piece of software on the box. When you want to deploy DEF and GHI, you create a new cumulative list, being able to track the deltas between the previous and the new. When ABC changes from 1 to 2, you update your cumulative list, right? And then you put an API on your deployment database, get the configuration management system pulling into it. So this was good because it allowed us to actually deploy software in an automated way, which we couldn't do before. That was good. But it was problematic from the perspective of what I was talking about a moment ago, because systems were not really able to be isolated cleanly from one another. If we wanted to improve one, it was kind of hard to do it in independence of the other one. So we modified this along those lines that I was suggesting, where you identify a link, you try to break it so that you can provide simulated input, like so. Instead of having the API be something that informs the configuration management system directly, you have some independent process that reads from the software, from the system, the deployment database, what software is supposed to be on the box, dump that in a JSON file somewhere, have the configuration management system read from the JSON file. This is just an example, right? Then you can do things like completely exercise your system over here without having to worry about having a deployment database up somewhere, right? The deployment database system can go down, and you can still test the system on the right just by creating that JSON file. Or you can have calls to this guy over here to create the API or to make API checks without having to have your configuration management system be the one that's actually doing those checks. Your configuration management system or Puppet can be down, and you can still do checks to verify that the system on the left is performing properly. So those are just a couple of examples about how you might actually do something like this iterative process to try to make your legacy system less of a legacy system that kind of is informed by these three notions of truth that you find out there when you start digging into this, that are kind of obscured when you just go and you read articles on the web about how to do configuration management and release engineering. And I hope that it helps you someday when you find yourself in this situation. Thanks. Okay. Well, in that case, I assume that you're all stunned into a wider wisdom than you've had previously. So I'll be around if you have any questions. If you have a question, go ahead. I'm shilling for questions.
Talk about your experience in implementing these kinds of techniques and like how to minimize the number of like false negatives that I'm going to get, because I don't want to remove a ton of stuff and then have it fall over. And I'm afraid, like, because of my fears of breaking things, I'm not going to have any traction.
Yeah, I mean, do you know what the system is supposed to be doing?
Nobody knows what the system is supposed to be doing.
Have you? You're afraid to turn it off?
Yeah. Yeah, that's pretty much it.
Well, I mean, yeah. I mean, I guess the standard thing would be to make a copy of it. Can you make a copy of it?
Yeah, no, I can do, I am fortunate that most of it is a virtual environment. So I can, on an instance, shut it down, but
You can watch, you can check all, can you verify who's interacting with it? Can you like watch network traffic and see who's making calls to it, for example?
Yes, in most cases I can. I should, because, I mean, it's,
I mean, you know, probably, you know, I mean, you want to try to do, you want to try to figure out who's interacting with it if you can,
Right.
you know, which there are ways, raw ways of doing, you know. And then, you know, you could try turning it off at night, you know, see what happens.
I mean, I could do that. I'll stop and we'll check
Okay.
after. Thank you.
Any other questions? Yes. So can you speak a little bit louder? I'm a little deaf.
You said you missed lunch preparing your slides.
Yes.
Will these be posted somewhere
Will they be posted somewhere? That's an excellent question.
or available?
Yeah, so if you email them, I'll give you the address.
Okay.
They'll be
Yes.
posted with the top description on the web, on the U360 website. Okay, thank you. All right, if that's it, let's give our speaker another round of applause.
Thank you.